Hey everyone, it is Mr. Vargas here looking to help out Math 3 with homework 4.2, working on dividing polynomials today. Let's go ahead and review what we went over in class. Okay, so for problem number 1, we've got a polynomial on top. This is actually a quartic polynomial. It's got 4 pieces, 4 terms, divided by a binomial. Now we can do this two ways. I'm going to show you the first way that works all the time, and then I'll show you the second way, which is called synthetic division, and that works in very special cases for our bottom binomial. So the first way is through long division, and this looks a lot like what we did back in middle school and elementary school, but this time just with some polynomials. So I'm going to write out that top polynomial, 3x cubed minus 7x squared plus 9x minus 14, and I'm going to divide it by that bottom term, those bottom two terms, that bottom binomial x minus 2. Okay, and just like in long division, we are trying to figure out how this thing fits into this thing, the dividend and the divisor. Really what I'm just concerned with is this front term, this leading coefficient, this leading term here, and this leading term here. And I want to ask myself, how many times does x go into 3x cubed, or what times x makes 3x cubed? And the answer to that is just 3x squared. After I daddy divide, I can mommy multiply down. I take 3x squared, I multiply it by x. That gets me 3x cubed. But I must also multiply 3x squared by my negative 2, and that would just make negative 6x squared. Alright, after you mommy multiply, you can sister subtract. Make sure you subtract away the entire group. That's why I put it in parentheses, just to remind myself. Add the opposite all the way through. Alright, and we can subtract, those cancel out, and leave you with a negative x squared. Bring down your next term, plus 9x. Okay, now we can take x, divide it into negative x squared. How many times does x go into x squared, negative x squared? Well, that would just be a negative x, right? Because when I mommy multiply back down, negative x times x certainly makes negative x squared. Alright, now we just got to multiply negative x times negative 2. You get plus 2x. And then we can subtract. Add that negative all the way through. And this thing gets canceled out here, leaving you with just 7x. Bring down that last term, negative 14. Okay, and now the question becomes, how many times does x go into 7x? Well, that would just be plus 7, or 7 times x actually makes 7x, and then 7 times negative 2 would make negative 14. Sister subtract, move that negative all the way through, and this time we get a double cancellation, meaning you have no remainder. Alright, so this new quadratic, this new polynomial up top, is actually the solution, or the quotient after division. So I'll write that 3x squared minus x plus 7. Alright, let's move on to number 2, using synthetic division. Okay, and synthetic division can be used when our denominator is in the very special form x minus r. And here this might not look like x minus r, but it's just kind of in disguise right now. In fact, it's just x minus a minus 1, because the opposite of a negative 1 gets a plus 1. So here my r is just going to be negative 1. Alright, remember that. Let's go ahead and take that top polynomial, write it in descending order. Thankfully it already is in descending order, and now we can just work with the coefficients, and this is synthetic division. It's just working with the coefficients. So I'm going to write those out here. 5 7, -1, and -3. And I'm going to synthetically divide that by my r, which in this case is -1. Okay, here's how synthetic division works. You bring down your lead term, your lead coefficient, sorry, and then you're going to take your r and multiply it by your lead coefficient. That would just make a -5. Go ahead and bring that over to the next column. Now 7 minus 2 just gets you 2. And then you repeat the process. So now I would take -1, multiply it by 2, and that would get me -2. Combine those, combine this column, -1 minus 2 just makes -3. And then I'm going to multiply -1 times -3, which would get me a +3. And this time we also get a nice cancellation at the end, or we get a 0 at the end, which means we have no remainder. Now we can fill this information in, 5, 2, and -3, with our appropriate variables and their proper powers. So we went from a cubic function, we divided it by a linear function. So you can imagine this drops down to x squared, and then you would get plus 2x minus 3 with no remainder. So using synthetic division, your answer is 5x squared plus 2x minus 3. And that's it. Synthetic division saves a whole lot of time. Let's move on to number, I think, 8. Yeah, I'll go ahead and do number 8 for you guys really quickly. Okay, here we've got a polynomial divided by a binomial, and our binomial is in the form x minus r. So we can use synthetic division. I'm just going to write the coefficients of that polynomial in my numerator. Thankfully it is already in descending order, so let's just write those coefficients. Alright, now I can take my r. This time, since it's already x minus r, I can just use 6. I'm just going to use the 6. And let's begin the synthetic division process. Bring down your lead coefficient, and then go ahead and multiply 6 times 4 to make 24. -25 plus 24 just leaves you with -1. Alright, 6 times -1 would get you -6 in the next column. Bring that down, you get -2. And then 6 times -2 would leave you with -12. And 20 minus 8 gets, sorry, 20 minus 12 leaves you with 8. Okay, so now we've got 4. We went from a degree 3 polynomial, or dividing it by a degree 1, so you can imagine you're going to knock off a degree, drop down a degree. So you could write this as 4x squared minus 1x minus 2, and then this time we actually have a remainder of 8. And the way that we would write that is, since it's a positive 8, we'll put plus sign, and then we're just going to take that 8 and divide it by our original denominator, which was x minus 6. Okay, and that is our remainder. There's our answer. Circle it, and good luck with the rest of your homework assignment.